Hi everyone, today we are going to look at substitution. It's our part one. It is another way to solve for system of equations. Yesterday we learned about graphing and going into Desmos and graphing it through there and finding that solution. But today we're going to look at substitution method. It is another way to solve for that solution of your system of equations. So the first thing we're going to do is we're going to look at our equation. Notice how on our equations we already have a variable solved for. So in this first one, we have y equals 2x plus 2 and y equals negative 3x minus 7. So a variable is already completely solved for. It's by itself. So the first thing we're going to do is I'm going to take this first equation. I'm going to take this back part of it. So the 2x plus 2. And I'm actually going to substitute it in for the y in the second equation. All right, because if you think about the first equation, y equals all of this, which is the 2x plus 2. And we're going to actually substitute in or plug it in where that y value is on the second equation. So what does that look like? It says 2x plus 2 is where the y, this y was, okay? And it equals negative 3x minus 7, okay? So doesn't that look familiar? It looks like a variable on both sides, or what Mr. Joel and I sometimes call a three-step equation. So we're going to solve just like we used to do a few weeks ago, maybe a month and a half or so, when we solved equations. So the smaller variable, I'm going to move first by doing the opposite. So I'm going to add 3x to both sides. You get 5x plus 2 equals negative 7. All right, we have a two-step equation now. So I'm going to minus 2 to both sides. And 5x equals negative 9. All righty. So I'm going to divide by 5. All right. And now I know exactly what my x is. X equals negative 9/5. Okay, so this is part of my answer. I have the x and the coordinate, okay? So now I want to plug back into one of these top equations. I can plug this in to either equation. It does not matter which one. It will still give you the same answer. So I'm going to just go ahead and plug it into the top one. So I'm going to have y equals, I have 2 times my negative 9/5, and you can put this definitely in the calculator, plus 2. So let me go to Desmos real quick here. And we have 2 times negative 9/5 plus 2, I believe is what it was. Let me go back and check. Yep, plus 2 at the end. So it does all the work for you. You can leave it as negative 1.6. You could also leave it as negative 8/5. Either works. I'm going to leave it as a fraction since my x is already in a fraction. So negative 8/5 is my y value. All right. So if I write it as a solution, I want to write it in a coordinate. So I'm going to write negative 9/5, and my y value is negative 8/5. And that would be my full answer right here, because I have two parts. Okay, you have to have an x and a y, because we want that solution, that coordinate, where they intersect. So let's look at this next example. I'm going to use a different color. All right, so we're going to do the same thing. I can plug this top equation into that y value. Now, you might be asking Miss Smiley, what about the other way you could do it? And so I can plug this one also in for that top y if I wanted to, okay? It will work out exactly the same way. But for this example, I'm just going to keep plugging in that top equation that's already solved for into this bottom y value. So I have 2x minus 7 equals negative 4x plus 1. So try solving that. Okay, your first step should be to plus the 4x to the other side, and you get 6x minus 7 equals 11, plus the 7 you get 6x equals 18. Divide by 6, and you get 3. Remember, you're dividing by 6. So x equals 3. Great. That one looks a lot nicer than our first example, right? So we're going to plug this back in. Remember, you can plug it into either equation. I'm going to plug it back into my top equation. So y equals 2 times 3 minus 7. 2 times 3 is 6. 6 minus 7 is -1. All right, so you can leave it like that. The much nicer way is to write it as your coordinate, and you get 3, -1 for your coordinate. Alrighty, so let's go to some more examples. So we won't always have x and y sometimes, and sometimes our x's will be solved for. So we have on these, both of the x values are solved for. So we're going to do the same kind of thing. I'm going to plug all of this -y plus 24 into this x on the bottom equation. So let me write this down. All right, so I have my equation written in. I've substituted the entire top equation in for this x on the bottom equation. Remember, you can change the 1/2 to 0.5. You can change it to its decimal if you would like, but I'm going to add my y over to this side, and then that's when I will change it to a decimal for y'all. So I have 24 equals 1.5 y minus 3. I'm going to plus the 3 to the other side. 27 equals 1.5 y. Go to your calculator. In your calculator, you're going to do 24 divided by 1.5. Whoa, that showed up really weird. Okay, hold on, let me clear. 24 divided by 1.5. There you go, that's a lot better. 16. So 16 is your y value. Now, remember, you're not done. You've got to go plug this back into one of these two equations over here. All right, the easiest one is definitely the top one because you don't want to deal with that fraction again, probably. So x equals -16 because you're plugging that 16 in where your y is, plus 24. So what is 24 minus 16? Hopefully you said 8. All right. So again, we could write this as a coordinate. Remember now, though, we want to write 8 first because it's x comma y, and you get 8/16 as your solution to your system of equations. All right, so try this last problem. Notice how our variables are now c's and d's. That same thing. You can substitute y and x back in for them, but it's written a little differently. So solve. It's the same process. Substitute the first equation into the second equation is where I would start with. If I were to give you a hint, I would substitute this in for C on the second equation. All right, so you should have put -3d equals d minus 8, and then hopefully you can solve from there. So remember, I normally would move my smaller variable to the other side by adding it, but on this one, it would give me a 0 if I did that on the left-hand side. So I really want to subtract my d over to here. Remember, that's a 1d. So I end up with -4d equals -8. Okay. And then what I want to do is just divide by -4. So I can get d by itself. And that gives me a +2. So we are almost done. And now I'm going to plug this, remember, back up into this equation. The easiest one to do is really either of them. C equals -3 times 2, and C equals -6. You would have gotten the same thing if you plugged in to this D right here, okay? So how do we write this coordinate? Because it's not x comma y. Well, C is where we normally would write our y equals, right? So we're going to have C be at the end of our coordinate, and D would be where the x value normally goes. So we have 2, -6 as our answer choice. If you have questions, contact Mr. Jewell or myself.